My colleagues and I like to think in terms of something we call big tent AI, which is much broader than normally people would associate with AI.
Everyone is talking about AI, but are we talking about the right AI? Right now, when people talk about AI, they think about ChatGPT, deepfakes, and AI-generated art.
I do optimization, and I do a special kind of optimization where we can just solve. I think you see a lot of people now saying things, oh, that's irrelevant now because we can just train some deep neural network to do this. And I think that's not true.
The real AI revolution is not happening in chatbots. It's happening behind the scene in optimization, automation, and control systems that actually run the world.
I think is quite disturbing. I'm seeing people being trained only in these LLM things and have absolutely no idea how these other things work.
And today we have the perfect guest to break it all down.
The man who has spent decades solving the problems most people don't even know exist. The global expert in optimization and AI, shaping how industries from finance to robotic to climate tech make real-world decisions. Professor Stephen Boyd, Stanford University.
Please, whatever you do, please go back and learn the basics.
Professor Boyd, welcome to our show. So today we talk about AI optimization and also data transparency. Right now, AI is being framed almost entirely around large language model, but isn't AI revolution is happening somewhere else?
I'm not sure the real revolution is happening somewhere else, but my take on that is my colleagues and I like to think in terms of something we call big tent AI, which is much broader than what normally people would associate with AI. I mean, right now when you say AI, people think of large language models and things like that, which frankly are stunning. I mean, it's unbelievable what they can do in terms of like generating code, summarizing stuff. If you can say, write me a poem about something technical, you'll kind of get it. I mean, it's amazing. So I think when people just think about that alone, that's kind of very narrow. My colleagues and I think of something called big tent AI, which has it encompasses basically a huge number of methods that use data, algorithms, right? And to build models of things and to actually come up with good actions. And so this would include many other fields, and some quite conventional, like just simple machine learning, statistics. It would include optimization. It would include things like control systems, right? So these are in some sense much simpler things that have been around for a lot longer. But we think of I think of all of these as being part of the AI family. And right now there's just a lot of attention put on, and rightly so, on these basically spectacular achievements that people really don't understand. I don't understand them, but I know people who would understand them if anyone did, and they don't. So
as you said, it's a big tent, so it's a huge field. Can you tell us what areas should we paying more attention to?
I can. I think the principal axis, the difference of all these different types of AI technologies, at the one end you have things like LLMs that do stuff people don't really know how they work, but it is spectacular what they can do. There's no doubt about that. At the other end, you have these technologies that have been around for hundreds of years that just kind of work. Things like automatic control systems. It's how airplanes fly. It's how the generators come on and are regulated so that we have electricity here. Right? That's how that works. It does these things do a lot of other stuff. And then you have sort of everything in between. I think some people now either do not know about these simpler technologies, or actually I see something I think is quite disturbing. I'm seeing people being trained only in these LLM things and have absolutely no idea how these other things work. I mean, what you really should know is you should know about the full spectrum. Even if some are boring and not as sexy as the new stuff, right? You should know about the whole spectrum. And then each of them has things they're very good at and things they're very bad at. I do optimization, and I do a special kind of optimization where we can just solve these problems, and that's actually it's a very good thing to use. I think you see a lot of people now saying, oh, that's irrelevant now because we can just train some deep neural network to do this, and I think that's not true.
So you were talking about training. Are we training our engineers for the wrong AI?
No, I think, look, if I were young, I would also work on these fancy new things. I think they're just amazing, right? The thing I am concerned about is that I'm now seeing people who are trained in these fancy new methods who have absolutely no idea about the existence even of these other areas. These are the things that actually work, right? And in fact, I think that if you're going to work in these areas, you need to know about all these things, right? So I don't know that we're not training people in the wrong areas. I think it is wrong to train people only in LLMs and deep neural networks when they don't even know the most basic stuff. It's not like it's complicated or anything like that.
If you were designing an AI curriculum from scratch today, what would you focus on?
So it's a great question. I would insist on including first the simpler methods, just ordinary regression, logistic regression, feature engineering, these very, very simple things. I teach people about basic optimization. Just it's not like I would have multiple courses on this, but I would do that all the way up through the very fancy stuff. I think what's unbelievably important, especially right now when things are going crazy, is that people actually have clear thinking. So I think it's unbelievably important not to dive in and say, look, this is how you do this or that, and you could use this, and the most recent model from 6 months ago is this. I think what's very important in a thing like that, where everything it's changing very rapidly, the important part is clear thinking. So this would be on formulate a problem. How do you clearly formulate a problem? It sounds very simple. It's a lot more complicated than you think, and a lot of people don't do it. They just dive in with some method. And many times I find myself saying, well, slow down. Tell me the problem. And then they start telling me about a method, and I go, no. A problem, you can't mention the method. Please tell me the problem. After they've given me a coherent description of the problem, then I would ask, how would you know if you're doing a good job? Which is a very simple question. And again, they can't come back with a long string of mathematics, or then they certainly can't refer to a method. They just have to say, well, my job is to predict the demand for these products in hour-long categories, next week, given all the information available to me now. That's the problem. How would you know if you're doing well? Well, we could look at historical data. I can apply the method, pretending I don't know the future, and look at it and just see how well I do. And we would just say how we would measure how far off you are. Right? That's how you do it. And this is before we say anything about a method. So I think this is what I'm seeing lacking, is that people are not getting just the very simple basic ideas. It leads to a very low level of clarity of thought. And then I think things just go downhill from there. So I'd make sure to teach those.
Oh, wow. That is mind-blowing, actually, because I feel like that kind of curriculum can be applied into many fields, not just AI.
I agree with you. It can be.
Yeah.
But I think what's interesting is as the methods change every year, they improve and all that kind of stuff. I think it's unbelievably important that you go back and teach the basics, right? And the basics is independent of what a method is. This is the problem. How do you state this clearly without talking about a method?
Yeah.
You don't say, oh, I'll use a regression model or something. You don't say that, or I'll use an LLM. No, you just say, this is what I would like to do, right? I want to make a system that will match job, let's say job postings with candidates. There. I didn't say LLM. I didn't say anything. How would you know if you're doing a good job? You'd say, well, I have some historical data that shows me the candidates that were available for a job opening, and we can actually find out who they actually finally made an offer to. And you'd say, then I'd check myself by looking how often did the system agree with that. right? So these are the basic things. And I didn't say anything at all about how I was going to do it, right? So I think this is what I see lacking.
One of the biggest reasons why AI is moving so fast is open source collaboration. I don't think it's true for data. So what are your thoughts about it?
Right. So, I mean, the first thing is unbelievably important. It's important to me because many, many people don't understand how it is that open source is driving innovation, right? People focus on, I'm from the heart of Silicon Valley, right? I mean, that Stanford is the epicenter, right? So of course, I see all sorts of companies all around me. I see the Googles and the everything. We see all this, right? That's awesome. I think that's great. What people don't appreciate is, very quietly, is the fact that a lot of this is built on open source stuff, right? Everyone would recognize, Bill Gates or something like that, but not many people would understand a lot of this is just based on open source software. So I think it is if you think about what's the magic, let's say at Stanford, the magic would be, to make a caricature of it, it would be that two kids, a couple of kids, by kids I mean undergrads, say, would, have some beers on Friday night and have an idea. And by Monday morning, they would have a working prototype. Okay? So how does that happen? It happens because they build on top of open source stuff. Or these days, it's not just that they have Linux and things like that, but they also have things like these open weight model, LLMs, right? So you can build stuff. I think this is unbelievably important because you could imagine another world where everything was proprietary. They couldn't even fire up an operating system without without paying for it, right? Everything was secret. And I think in areas like that, you don't see innovation, you don't see growth, right? Or another way to say it is, when I look around my colleagues across the university, the fields I see which are very vibrant and growing quickly are the ones that have embraced openness. The ones that are growing slowly, I might even say stagnant, are the ones where it's all secret, everyone's trying to patent everything and trying to start a company and things like that. And I think, that's fine. Sometimes the right thing to do is to start a company, but I think and that's the thing I think most people would see immediately, but I think the open stuff is unbelievably important to innovation as a whole.
But it's not the same for data, right?
That's it. Yeah. So I think for data, it's a different story, right? What's nice about open source is it democratizes code, right? Less so with data, right? So that the advantage goes to large companies, large governments that actually have government agencies that have access to just enormous amounts of data. I think that's something that's kind of unfortunate. It's something where that's an anti-democratizing force, right? For example, I couldn't easily get hold of a lot of medical data, right? So therefore I can't it's much harder for me to do research on it. I could get it, but it would be a very long story and I'd have to run it on special computers and get special permission, all sorts of crazy stuff, right? But that means I can't really do research on it, right? So, now, there's a very nice thing happening recently where, for example, you'd build an LLM. Based on, this would be an enormous cost to train a model. It would use, let's say, everything ever written in the English language, or Vietnamese, Chinese. It takes a long time. And then people make the final weights of that model available publicly. I think that's really cool too. And then we can do things like fine-tune that. Basically start from that, which was obtained at enormous expense, and go from there. I think that's also kind of awesome.
So actually, Vietnam is on our way to build like a digital government. Mm-hmm. Now we do have an ID card. Now it's embedded to our phone. Mm-hmm. And the sad thing is our government, we don't know what to do with the data set. And I don't think that we are allowed or willing to share the data set with researchers or scientists. So can I have your thoughts on it? And like, what should we do? Even it's kind of a national security thing.
Absolutely, right. So, yeah, I think that there's trade-offs there, and that has to be done very carefully. And actually, not giving access before you actually think of what you're going to do is actually not a bad choice. So they might be doing the right thing for now, right? But it's a treasure trove of data, and it could be used for lots of very cool stuff, assuming it's distributed in a way that's safely and thoughtfully done, right? So, I mean, people talk about, so in the U.S. already, I mean, you have no actual privacy, right? People blabber about it all the time and say, oh, no. But the point is, lots of companies are tracking us. I mean, if you don't think my mobile phone is in my pocket, you don't think many places know actually they know what we're saying, they know what I'm doing, they know my email. So there is kind of no privacy, and yet people pretend it's a big issue with privacy. So I think these things have to be thought through very carefully. But if they're thought through very carefully, I think this is just a huge treasure trove of data. Medical data would be a very good example, right? So you could actually run public health really, really well, right? If the right safeguards were in place, access to this data would be stunning, and could be used for good, not evil, right? Yeah. Evil would be to try to sell us stuff or things like that, right? Or deny us insurance, right? That would be evil. Yeah. Good would be to actually tease out real patterns, to find out what are the minimal interventions we could do at low cost to actually improve health on the scale of a country, right? So
you were talking about like how open source transform technology and AI. Can you say it the same for data if it's publicly used and used in a good way?
So actually, if you look at sort of the history of AI, a lot of people, look at it. I mean, they talk about these data sets that were made public. I mean, some look very crude now, right? There was a set of things which were handwritten digits, on envelopes or something like this. I mean, it sounds silly, but this was a huge thing. There were lists of images originally put together by my colleague, Fei Li. And it doesn't sound like much, but this drove innovation and research. It supercharged it, because all of a sudden people had access, everyone had access to data sets that they could play with. And I just think this is awesome. I mean, so I think not enough people really understand how important making those data sets public really was. It's not exactly data, but I'll mention something else. I teach and I do research. And I've been very careful and kind of committed to making everything I do open to the entire world. So I just post everything. All my books, all papers, software, my courses, videos of my courses, right? And so I think embracing this kind of radical openness, I think, is a really good thing. Because it's great. I mean, so people all over the world watch these things. They're not great. They're not, professionally produced or anything. I mean, some are embarrassing. The videos certainly are, right? They're videos of my classes, and I make mistakes. I don't know, who knows? It doesn't matter, right? It turns out it's unbelievably useful, right? And it accelerates stuff. And it's not just that I contribute to it, but I also watch stuff. I'll look at my colleagues. I'll see, let's see what my colleagues are teaching, and I'll go look at a course from MIT and say, oh, that's cool. This is interesting. So I think that's a very good. I think that's very important. And if people can do it, I think they should.
For the last part, I want to talk about Vietnam a little bit more.
Okay.
So, do you think that we should run this AI race with the giants, or we can find a path of our own?
It's a great question. I mean, we have the same question with, like, can universities compete with companies, right? And sometimes, I'm in electrical engineering, and 25 years ago, my colleagues, who do devices and fabrication of circuits, they realized they can't. Samsung, or they can just do it better. I mean, because a fabrication facility costs billions of dollars, and we can't match that at a university, right? So it turns out there's still very good niches one could work on. You can still run cutting edge stuff, but it's not competing with these bigger and well-funded entities that have been doing this for a long time. So I actually think, especially in this kind of AI revolution coming up, and even this in Big Ten, certainly Big Ten AI revolution, there's just a ton of stuff people can do, which will use this stuff, where you don't need to have a giant farm, multiple server farms and stuff like that, or the most cutting edge GPUs. I think Vietnam could easily, if they don't focus on getting into the going head to head with Meta or something like that, I don't see any reason why they couldn't come up with all sorts of awesome applications. And hopefully, if they do this in a way that's open, they'll come up with solutions and applications that will translate to other developing countries, which should be awesome, I think.
For the final question, if you could give only one piece of advice for young engineers entering the AI space today, what would it be?
That's a great question. I would say by all means, look at all the coolest methods that people have just developed in the last few months. Please do. I mean, it's moving quickly, it's awesome, it's fascinating, do that. But please, whatever you do, please go back and learn the basics. As boring as it may appear, and as useless as it may appear, please go back and learn. Also, keep your wits about you, and make sure to ask yourself every now and then, what is the problem? Without any mention of what the solution would be, or the method. And also, how would I know if I was doing a good job? So I think as long as you keep the basics like that in mind, and know basic things about optimization, about automatic control, about basic statistics, about simple methods. Just keep those in mind when you go off and learn these fancy new techniques.
Thank you so much.
Sure.
Yes. Thank you so much for joining us today, for agreeing to doing this.
Sure.